Hello, welcome to part 3 of the tutorial series on mathematically attaching actors with quaternions or whatever in blueprints in Unreal. Uh, Thanks for sticking around. Let's first show you what it looks like when it's finished. The completed version, if I can please. All right, there we go. And hit play. I can move it around, rotate, move you around, rotate you. And I can continue to move them around and the rotation will stay the same. So I'm going to delete this guy. So we're going to build this guy out so that way he can do it. Right now at this stage in the tutorial series, we can basically do this where we can move the guy around, but we can't really move the cone around. We can't rotate the cone. So we're going to fix that. So first things first, we're going to go inside of tick transforms and we're going to move these a little bit farther away from that. And we're going to break that. And this part, we can disconnect that. So let me move this up actually. So first let's start with location, because location is actually going to be easier for me to explain. Actually, no, let's start with rotation. Rotation will be let's start with that, the more difficult one. So this one I can't really explain with these guys because, well, actually, no, I can. So let's do it like this, where I also move these in here just to make it easy for explaining everything. So first, I'm going to do is explain, we're converting a local, this is in local space, and this is in world space. So this would be the center of the world for the chair. That's essentially where the chair is, and this is where the cone is in relative space of the chair. And then in world space is what is really happening. Um, so let's this this property would be the same as the orientation of the cone, the rotation. So the x, the y is like that. So when we call this function, we're basically saying, okay, let's convert it back into world space like this. So when we do that, we also need to be able to know, like, okay, what if we rotated the cone, like 90 degrees or something? So now it would be like this or whatever. So then it would be like that. Sorry, let me do this actually. So it would be like this. Also, sorry, you might hear my cat just meowing in the background, trying to get my attention. So it would be rotated like this, and then basically, like, we need to be able to actually retain that information. So the best way I can explain it is, oops, yeah, it's just complaining about that. What we're going to do is after it has been converted out into world space, we're going to convert it back into relative space, but of the cone, not of the chair. So it's like we converted it into the chair's relative space, and then we converted it back out into world, and then we're going to send it into the cone's relative space. So in the cone's relative space, we're working at center of the world, and we're working with default or identity orientation. That's what it's called. Identity is the default orientation where everything's 0, 0, 0 or whatever. And the offset, so the offset would be like over here, and then, I don't know, like right here or something. I'm just doing like that. So that would be the offset, essentially, the new rotation, the one that's farther away from the box here. So now we have that offset in relative space, we can count that as our difference. So it's like 3 mini cubes or whatever rotated. So then what we need to do is we need to convert it back out into world space. But if we do that in the cone, it's just going to sit there and it's not going to rotate because it's going to be like, well, that's just going to be in my space in the world space. But what we did was we actually stored the initial rotation in the world, like from begin play when we were storing these values, when we were calling store transforms. So that was a different rotation altogether. So then when we do these when we convert it back out, we're like, okay, well, let's apply that difference to the one that we stored. And that causes it to allow us to have this difference be applied to the new rotation. So then it's like, okay, we're gonna move the rotation, this frame. We're gonna rotate to this new orientation based off of, we're gonna apply a difference basically. So we got a difference in relative space, and then when we use the stored value and not the current one, because the current one's just going to be the same value, it's going to be zeros. It's going to basically say like, oh, I haven't really changed. But if we use one that we stored from a previous frame, we can basically say this is our difference. We want to apply this difference to you now, which will basically, I'm trying to figure out how to explain this. It will basically cause the change to happen, and then we can store that change for future frames. Um, so first, let me start getting the part about converting it in the local space. So to convert it in the local space, hopefully you've been paying attention. We can just grab our current rotation, inverse it, and then multiply. Oops. So now it's in relative space of our cone and not of the chair. Okay. So then we're going to grab our stored value, multiply that. And this will, and an important part about multiplying with quaternions is that not only does it convert, but it also applies, you know, the difference. So it's like, it does, it's basically a combination of, um, if I was to do do this operation and then like an add or whatever, or did like a plus kind of thing. That's basically what happens when you multiply these kind of values together with quaternions. And honestly, like, you're not going to be able to get this by planning it kind of thing. Like, I highly suggest just like playing with it, see what the values end up being. Like, this was through trial and error in some cases, where I just need to know which value was the correct one to convert out and then multiply by. But it's just playing around with it. Um, Eventually you kind of get a read for like how to do these sort of things within the correct spaces. Um, so like don't get frustrated that you're not understanding this immediately. Really, it's one of those things that you just have to start playing with it and really like get a feel for it. Um, at least like that's the way I can understand it, and explain it to people. Um, you may understand it differently. I'm just being honest with you on that. But hopefully it was helpful in making sense of like this part converts into this part converts it from local to world of the chair, and then this part converts it in from world to local of the cone. And then this part converts it back out into the world, but of a previous cone. So, um, local to world via previous cone route. And then let me actually move this guy out of the way. I can do world to local of current cone. And then this part is local to world um, of chair. But yeah, so that basically kind of gives us like a difference as well. Um, So now we can start on the what's it called? The location offset, which is it's a little bit more like simple to explain, at least for me. Um, so first we're gonna convert this into, yeah, so local to world location of in of offset initial offset. Okay. An important part is that I also forgot to mention is we're going to store the transforms again now that we've set the new location because we're using like, values that are getting updated every frame now that need to be updated every frame, which is like, local to world via previous cone rotation. It's like, well, we can't do it every frame because then it's just going to drag off and go do its own thing. So, um, first, let's do this. Offset. Um, this guy, he's like that. Apologies. Um, so what we're going to do is we're going to calculate the offset. What's wrong one? Actually, do here, offset. We're going to calculate the offset between, actually, no, sorry. I'm doing this backwards. So let's say in the frame we've moved the cone, so it's in a new position. So new cone position. Okay. So now we have let me actually, sorry, my cat needs needs me to play with her at all times. So here's our offset. Actually, sorry. I'm just explaining this poorly now. This is our offset from old to new position. So this is from our old position. This is our new position we're going to interpolate to. Hang on one second. Okay, apologies for that. My cat was absolutely losing her mind right now. Um, anyway, so we have the new cone, we have our offset. We need to calculate our offset between the previous frame and the current frame, and then we can add that difference onto our resulted cone location that came from like the relative offset. So like, let's say the actual cone's location, actual cone's location, yeah, is over here, and then like this is the one that got converted out. So like this is the um, relative converted cone. So we need to apply that offset here so that way we can move it over to like the correct spot. So we're going to do that. Whoops, wrong one. Current location minus initial, nope, not local, initial location. And then we're going to combine the two. Let me comment this. Find current offset in the world. And this is us basically appending offset to the converted world location. Okay. So we're not actually favoring our actual cones. We're not favoring our actual cone's location. We're favoring the relative cone in like the chair, essentially. So then from there, we need to get the difference from our current location. Cat, now is not the time. Yeah, she's desperate for attention right now. Yes, I love you too, cat. But you're getting to hear some prime cat attention. But yeah, so then what we're gonna do is we're gonna get the offset from the actual cone. So offset from relative cone to the actual cone. Okay. And then we're going to add that offset to our current location of the cone. So then this will actually move it, you know, in the correct direction. So we actually, when we try to do the offset between the chair, it's basically going to push the cone. Um, when we move the offset of the chair, it's going to apply that offset with, the cone. The cone's like intended offset, I guess. And it's going to move it over to where it should be. So let me actually explain this better through text. Um, find difference of current location and the offsetted. Okay. And then from here, apply that final difference to our current location to offset it to the correct position. But at this point, like, as you can tell, it's basically just doing like simple vector math for the location offsets. And for the quaternion math, it's just understanding like what operations to call, which is really just calling inverse to convert it to local and world, and then multiplying. And then like inputting the correct properties and values for that conversion and for that math. Like a lot of this, a lot of this is pretty much the same sort of concepts that you would do if you were doing some like building a portal in a game where the camera needs to be in, relative, to whatever your camera is or whatever. So you can see through it and it looks correct. Another one is how Sea of Thieves does it, where they basically would have a static mesh of the ship off somewhere in the world and just use that as their navigation mesh. And they would project the players and the AI's locations onto that and just do the calculations there rather than need to do them like in the world when the ship's rotating and all that fun stuff. It's like the ship doesn't need to have a nav mesh on it. We just need it to basically have the same exact dimensions as the one that the nav mesh one does have. And then it can convert back and forth kind of thing. So, oops. Why can't I see anything? Sorry. OBS seems to like break Unreal Editor for me on my Windows, but I can see in OBS it seems to look fine for you. Anyway, let me hit play. Oh, why did it freeze? There we go. We can move it around, can rotate it, can move it up and down. Oh yeah, we can also rotate, and this will rotate with it. Because when we break it apart, like this part is the part about it converting over, and then these parts are us just dealing with the appending. So this is in relative space of the chair, and the rest of it is just dealing with appending any changes that we have. So hopefully my ramblings were actually helpful in these tutorial series. I definitely feel like the third one was not the best, but it's that kind of thing of like trying to explain like exact details of why I'm doing like some of the rotational math, um, especially in a way that avoids like using, like subsequent transformation, logically first, composing, like those kind of words. It makes it difficult. I'll be honest with you. So a lot of it's like I'm trying to explain it like you're converting it into local space to do this and rotate it over and get a difference. And a difference is pretty much just, like an offset essentially. So again, hopefully these videos were helpful. Please comment and let me know. I genuinely enjoy seeing little comments of like, oh, this was really helpful and stuff. So hopefully you have a great rest of your day